Hello everyone and welcome to this new video. So today we are going to solve the first problem of the project Euler using Python 3. So the Euler project is a famous one, so they do have a lot of problems to solve, like more than 200 problems, and they are challenging us to find new ways, okay, to solve problems. So let's dig into it. So summary. In today's video, we're going to solve the first problem, as I told you, of the Euler project. We're going to solve it with two methods, okay? So we will have a simple function and a recursive function, and after that, we will see which one behave better than the other, okay? We will see which one will perform better. So, and see which one is faster, okay? So I'm going to use Python 3 with some libraries to simplify the solution and to explore the performance of each solution. So those are my own solutions, but you can find others and maybe can perform better than mine, who knows, okay? This video is made for educational purposes only, okay? So let's dig into that. So first, let's explore the problem. So here is the problem. The problem says if we list all the natural numbers below 10, that are multiples of 3 or 5, we get 3, 5, 6, and 9. The sum of these multiples is 23. So they asked us to find the sum of all multiples of 3 or 5 below 1000. So let's see what's happening over here. It says to find the sum of all multiples of 3 or. The key word here is or. So or over here is very important, okay? So they say or 3 or 5 below 1000. What does that mean? It means that we are going to use the or, okay? So they didn't specify if we should make an algorithm, okay? So one of the solutions can be by writing down on a piece of paper the result after making the calculations, okay? Somehow. But in my case, I will make two algorithms that can solve this problem automatically using Python 3, okay? So the OR is important because we should look for all the multiples of 3 or 5, which means if there is a multiple of 3 but it's not a 5, it's not of a 5, we should count it, okay, on the sum. And if a number is multiple of both, we should count it only once, okay? So the below means that 1000 should not be taken into consideration, okay? We will get rid of 1000 because it doesn't mean a lot for us, okay? Say they told us below 1000. So we have explored the problem, and now let's dig the first solution. So this is my first solution over here. There is this function which is called def mu3, and then I passed to it the range, okay? So multiples of 3, I created an array of multiples of 3, and then it went on a for loop, okay, through the range. And if uh, e modulo 3 is equals to 0, or e modulo 5 is equal to 0. So this or over here is same thing as here, the or. So 3 or 5. So I put it down on an array, on this array. The multiple of 3, this I forgot about it. The multiples of 3 or 5. So I should add over here a 5, okay? And then I appended the value to this array. And at the end, I have returned the sum, okay? So the sum here, I've put it the sum of this array. So I return the sum. So let's see what I wrote here. So here's the function that will make the calculations, okay? I've used the for loop that will go through the required range and in our case it was 1000. So the 1000, because over here I've passed it as an argument 1000, because here it would count 999. Okay, it won't count as 1000. Okay, because it starts from zero, and zero is not counted. Okay, so I wanted to make it so through the required range. In our case, it was 1000. I wanted to make it open so I can use it however I want. So I put the range they specified for us 1000. So I didn't want to make it static. I wanted to give it a range. Okay. So this is the call. As you can see, I've made a counter to see how much time it would require to make the calculation. So over here, I put a start and stop. So I call this method from time. I imported time and I've used this method. Okay, and then same thing over here from the start to the end, and at the end, so I put the stop minus the start to see how much time. So here's the sum of the normal function. So this is the solution. And here is the time it took to make the calculations. So this is the time to make the calculations. Okay, this is the spent time. So this was the first solution, and now let's see the other solution. So we are going to use on the second solution a recursive function. Okay, so this is the second solution. So here, as you can see, it is the same logic, only it's called itself. So over here, so mir3 recursive. Okay, I put only three because three is my favorite number, so I didn't put the five. So I should put the five over here. Okay, or it will be misunderstood. So I put def mir3 rec and then table and the range. So it's not over here because only over here it took only one argument. Okay, on this function. But here it take two arguments, so we can make it as short as possible and to not take a lot of RAM, okay, and CPU usage. So I put it as simple as possible. So I make a condition. I've made a condition at the beginning. So if the range is less than zero, so I will return the table. Else, if the range is modulo 3 equal to 0, or the range modulo 5 equals to 0, then I would append the range, the number, okay, because the range is going to be decremented each time this function is called, okay, in order, so from 1000 to 0, each time it will decrease by 1, okay, so it would call itself over and over and over until the program finishes. So if it's less than 0, I won't call it back because over here I've called the recursive function, and over here I stopped the recursive function. Okay, and by the end I returned the tab. Okay, so when I returned the tab, this is the final result. Okay, so let's read what I wrote here. So this is the second solution. As you can see, it's a recursive function and it will keep calling itself until the final condition is met, which is this one over here. The range is less than 0. So there is the same thing on the previous function, except that this time I've put two arguments for the function. There is the table and the range. The conditions of the divisions are clear through the if statement. Okay, the if statement, and they put the condition if it is modulo 3 equals to 0, and or the range modulo 5 equals to 0. So the result I will append it to the table, okay? And so here is how I have made the call. So I've initiated a table to this one, so it's none. And then I've called our function over here, and then I've put the sum. Over here, it's included on our function, but over here I didn't want to make it longer, so I've called it after the argument will be received, okay, after the call. So I put the sum over here, and then put it on the variable of sum, okay? And then I put it at the beginning the timer, so I put time and the time, the start time and the end time, and then I printed the results. Same thing as the previous function, okay? So here's the result, as you can see. Uh, Here's the result. Here's the sum of the recursive function. This is the sum that they asked us for, and this is the time that it took for the function to end. So as you can see here, there is a huge difference. So over here there is 40, there is 30 and 9. Over here there is only two zeros and 1, which means that the second function consumes a lot of time and a lot of resources. And now let's explore which function is faster, okay? So the first function or the second function. Based on those times, this one is the first function consume less time, and the recursive function consumes a lot of time. So by using matplotlib, and with multiple tests through a loop, this result shows how effective is the first function. Okay, as you can see, there is a huge gap in between, and the ultimate winner is the normal function in that case. Okay, so there is other cases where the recursive function would win. Okay, so over here, as you can see, the required time would grow each time. Over here, for example, on the test 0, we do have only 0.00025, and it's more than double. On the second test, it is a lot more than double. It is 8 times or more. On the third test, okay, and it keeps there is a gap between them. Okay, this gap is usually going up, and it's stabilized over here. This is, I guess, the lag in the time where the first function took a lot of time to proceed. Okay, so as you can see here, it's not static, it would change. That's why I wanted to plot it on a graph. Okay, so what to learn from here? So there is tons of solution out there, but the one that stands out is ultimate goal. So you have to keep it on your pocket, okay? If you want to solve something, you have a pocket of your own solutions that you know what they can do. So it is a special pocket that you would use, okay? It would make you give you better results. So if you have a solution, it's better to see it through all the ways. Okay, you won't get satisfied by only the solution, but what it's going to do. Okay, on the long way, on the long road. Sometimes something may hold the road, but another can hold for a longer road. Okay, it's never about the solution, it's about the how. Okay, so those are two solutions. As you can see, the first one performed better than the second one, which means that there is always new ways to see things. Okay, so don't get stuck only on by one solution, and see other solution and how they are going to behave. This is only one point of view, so there is a lot more points of view, and you are free to see them, to look at them. So now let's continue. Let's look at the code that I've used to create this graph. Okay, so this graph, I've used a function one time to store the time, as I explained over here. In order to store the time, so I've put it. So let's read this one. So this was pure code. I've made a loop to go through the calculations, and I've made 10 because the time was changing after each time. So each time I tested. Okay. So I wanted to see what's going on. On that loop, I've called both functions for the same calculation and stored the time in an array for each function. Then I've plotted those two arrays using matplotlib, and voila. Okay, so this is the loop for e in range 10. So I've tested 10 times. So there is the T1 start. I set the counter, and then start counter and the end counter, and then I appended the stop minus the start to our function one time. And then I done the same thing for the second function when I where I put the start and then I put a tab. Okay, so I guess that yeah, I put the tab equals to none, and then after that I put the sum and I put the stop, and same thing I appended the, the second time stop minus the start to our function two time. Okay, so there is fig. I've plotted it, so I didn't show you how I imported libraries. So I've put it through that way. I've made two plots. Okay, fig and x, and then I put the index through a range of 10. So, and then I put it the width of the bar and the opacity, and I print the function to this one. I've printed it only to see that it is correct. It is the correct time. Okay, so there is no null values because this function over here would give back some null values. It won't count sometimes. That's why I changed it to this function over here, frame point perf counter, so it's behave better. So I put the first plot and then second plot, and then I put the X label and Y label, the title and the legend, and the site layout, and pretty.show. Okay, and it show me this figure. Okay, it is quite simple. So yeah, this is it for today. So where you would you find the code? You will find it on this link. I will put the links on the description of this video. I really hope you enjoy it. Thank you for watching, and bye bye.